Alright, hello, this is going to be Solidworks CSWA practice problem 9.7, and if you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. This is going to be assembly, so let's set our base part, which is going to be our connector. Click the green check mark to fix at the origin, and there you go, it's fixed. So let's just get all the other parts in here. Let's get the arm. Let's get our shaft. And let's get our bearing. So first of all, let's get the shaft in order. So I'm going to make the whole of the arm and the shaft concentric to each other. That'll be our first mate. Select OK. And now I need to center the width of the arm inside of the center of, or in between the in between the gap of the shaft. So we're going to go to Advanced. We're going to click width, and the first width is going to be the inner width of the shaft. Second width is going to be the width of the arm. So now the arm is going to be centered inside the shaft, as you can see. So we'll select OK. Then from here, from here, I'm going to go back to standard, and I'm going to create a mate. If you see this little slit on the bearing, this is actually a hole cut, kind of a half hole cut, and that's supposed to be concentric with this hole at the top of the shaft here. So that's how it's going to be aligned. So I'm going to click it, and click the hole at the top of the shaft, and now it's concentric. And then we'll just make the middle hole concentric with the top of the shaft. And so now it's concentric and aligned. So now all we need to do is constrain the bearing to this slot where the bearing is supposed to be. And let me see. Let me see how this bearing is supposed to fit. I'm assuming the bearing is supposed to fit right here on this top edge right here. So I think that's where I'm going to put it. So I'm going to click the bottom of the bearing, and I'm going to click the first flat surface here. Click OK. And then I'm going to, let's add a concentric mate between the top cylindrical part of the shaft and this hole. Select OK. And that should be correct. Yes, that's correct. Okay. So then, now for the angles. I had to re-record this video because the first time I got stuck on the angles completely because I didn't realize that you were supposed to enable plane view of the individual parts for the angles. So I guess we'll start with our 128-degree angle. So the view, actually hold on, let me bend this arm a little bit. Yeah, like that. So the view is kind of like this. And the arm is supposed to be bending, well, like the shaft is supposed to be bending like this a little bit so that the arm is like somewhere around here. So we'll need one plane of the shaft, and then I guess we can use this face right here of the connector to make the angle. So I'm going to click, well, first of all, let me show the planes of the shaft. Let's see. Planes, planes, planes. How do I show planes? Planes, planes, planes. Maybe it's in the eye? Oh, here we go. Okay. Or maybe I can show the individual plane like... Oh, I see. Wow. So if you click on the part and you click Q, it automatically... Wait, hold on. Let me do that again. So I click on the part and I click Q, and it shows the planes for its individual... for the individual part. Okay. So... I guess I'll do this. So the angle is going to be 128 degrees, and it's going to be between this face and this face and I believe the right plane. The right plane. Right, because right plane cuts through the middle of the arm, so it should be right plane. But let me show that again. So it should be right plane, like this. And then we'll flip the dimension. Actually, we won't flip the dimension, we'll flip the alignment, and then flip the dimension, like so. Okay. Is this correct? Yes, that is correct. So I'll select OK. Hide the plane, and if you look from the top, it should look exactly like the drawing, the top view drawing. And then now the second angle, using a similar method. This time the angle will be kind of from this angle right here. So we'll need to find the plane that cuts through the middle of this side. Let me see. I guess I'll show the planes first just to make it easier. Let me see if I can catch anything. Here's the planes here, and here's the planes here. So I would want the angle to be between the front plane of the shaft right here, between the front plane of the shaft and the what is this, the right plane? No, that's the front plane. Front plane of the shaft and the front plane of the arm. So that way I believe the planes will be perpendicular to each other, right? No, they'll be parallel to each other, but they'll be at an angle to each other. I wish I can like keep the planes there so that they can just stay there. Let me see. It's weird. But anyway, I'm gonna go to Mate. We're gonna click our angle. I'm And then 45 degrees. I'll click the shaft. Oh, actually, let me do that again. So the angle's 45 degrees. I hold Q, shaft. And I'll select its front plane. And I'll hold Q on the arm. And I'll select its front plane. And I'll make it 45 degrees. Let me see what happens if I flip dimension just to make sure it's correct. Yes, it's correct. Okay. So click OK. So now both angles are in place. So that should be the final part. So let's check our answer. I'm gonna go to Evaluate, Mass Properties. For my X, I'm getting. Oh, wait, hold on. Wait, let me double check this is correct. 128 degrees. So the 128 is still there. And then the 45 from this angle, still there. And everything else, yes. Okay. So my answer I'm getting is going to be, the X is going to be negative 14.54. The Y is going to be negative 73.17. And the Z is going to be 10.47. And that is the center of mass for this part. So I hope you learned something from this video, and I'll see you in the next one.